Okay, today we're going to take the derivative of arc hyperbolic sine x, which from now on we're just going to be calling hyperbolic sine x sinh x, which means that this is going to be arcsinh x, because that's just a lot easier. I was very happy when I heard that that was something that people said. So we're going to let that equal y. So we're going to let arcsinh x equal y. And we're going to look at the inverse relationship, which states that sinh y equals x. Well, as with all of the other proofs of the derivatives of trig functions, not the hyperbolic ones, but it does hold up in the sense that the derivation is similar. We're going to use implicit differentiation to isolate dy by dx, which is the slope of the tangent line. So let's take the derivative of this. We're going to have dy dx of sinh y equals dy dx of x. Well, there's a chain rule hidden here because there's a variable mismatch. The outer function is sinh x and the inner function is y. Well, the derivative of sinh x is hyperbolic cosine x. So we're going to apply the chain rule and we're going to get hyperbolic cosine y times dy by dx equals 1. Now we're going to divide by hyperbolic cosine y and we're going to get dy by dx is 1 over hyperbolic cosine y. Well, what do we do with that? I mean, there's a y in the denominator. If we leave things standing like this, we can't go back to our original notation, right? And we want to. So we're going to use one of the hyperbolic trig identities, one of the fundamental ones. And there's actually a video in which we prove this. But what it states is that hyperbolic cosine x squared minus hyperbolic sine x squared equals 1. And if we just add hyperbolic sine x squared to both sides, we can isolate hyperbolic. Actually, let me make this y. Let me make that y. I know that doesn't look good, but you can tell it's y. Because even though it doesn't matter what the variable is for the identity, for this particular problem, it'll be helpful to see that it's y. So we're going to end up with hyperbolic cosine y is the square root of, because there's a square here, right? So to get it, we need to take the square root of the other side. 1 plus hyperbolic sine y squared. Well, we know that hyperbolic sine y is x. So this actually is the square root of 1 plus x squared, which means that our solution looks much better now because we can write that dy by dx is the derivative of arcsinh x and equals 1 over the square root of 1 plus x squared, and that is much better. And that's our solution.